Okay, so this one is practice problem. So practice problem yet again, unit 4 and lesson number 10. Okay, let's see how this to be done. So first question is asked, use the base to log. So basically you're using base. So I'll go straight away the base. We know that if this is the input and this is 2 raised to x, and we should be knowing by now if it is 0, it is 1. If it is 1, it is 2. If it is 2, 4, 3, 8, and you can see how many times you multiply and so on, right? So using this table, we can clearly, we can easily figure out what is 2 raised to 5. So 2 raised to 5 is here, 32. So that's the easiest one. What about this one? Now, they did give us this one as 2 raised to 3.7. Now this will be between 2 raised to 3 and 2 raised to 4 because 3.7 is between 3 and 4. So we can say, hey, 2 raised to 3. So this is 2 raised to 3, which is 8. And this is 2 raised to 4 is here, which is 16, right? So that means this number, which is right here, is between, this will be 8 less than 2 raised to 3.7 is less than 2 raised to 4 is 16. So the value of 2 raised to 3, 4 is between 16 and 3.7. If you see this, 3.7, this 3.7 is almost close to 4, right? So maybe this number, value of this will be closer to 16. The next part is 4, the 2 raised to 4.25, and clearly see this will be between 2 raised to 5 and 2 raised to 4. 2 raised to 4 is 16. 2 raised to 5 is 32. And you can clearly see 2 raised to 5 is 32. So this number value is between 16 and 35. We'll use the same base to log. So what is that means is basically is that this is the same table that you have seen this part. It's like you have another table gives back that if this is x, then this is logarithm of x to the base 2. So I remember, if I forgot here, if this was minus 1, this is 1/2, and this is minus 2, this is 1/4. So this one will be giving you back the same thing. So if it is 1/4, the answer is minus 2. If it is half, it is minus 1. It is 1. So input output becomes output input. See? So this will be 2, 8 goes to 3, 16 will be 4, and 32 is 5. So logarithm means asking a question, how many times you multiply 2, this is the base 2, to get whatever that input right here. Okay, let's go. What is the meaning of this first one? See? Very easy, right? And logarithm of 4 to the base 2. And just imagine you don't know. I'll put a question mark. I don't know. So it's asking to this 2 raised to the question mark is 4. And you can see this 2 times 2 is 4. So the answer is 2. So this answer is 2. That's all it is. Look at this number. Logarithm of log of 17 to the base. So we want to know this value, right? Now imagine if this was a logarithm of 32. And on the left, I will write logarithm of to the base to 16. So why did I pick this 16 and 32? See, logarithm of 16, that means what number multiply. So how many times do you multiply 2 to get 16? Its answer is 4. How many times do you multiply 2 to get 32? It is 5. And you can see this. So 32 gives you 5, 16. So the number, this number that you see, this number will be between. So this number, let's write it one more time like so. Logarithm of 17 to the base 2. So this value will be between 4 and 5. That's all they're asking you supposed to. So hope that helps. So, and that's the reason I picked the 16 and 32 is because logarithm of 16 is 4, logarithm of 32, and this 17, and watch this, 17 is between these two, right? So these are the main milestones that you have to think of and say, okay, now log of this. is same as log of 17 is same as log of 32, and then it is 2, 2, 2. And then you know the answer. And the last one is look at this 35. So this 35, which you see here, is 35 is between now 32. The next number will be, I can think of, uh, because if I take another 6 here, this will be 64. Because when you multiply 2, right? So therefore, 64, if we say 64, it goes back to 6. So I'm going to use 64. So this is less than 64 and less than 32, right? So this means when you take the logarithm of 32 to the base 2 is less than logarithm of 35 to the base 2 is less than logarithm 64 to the base 2. And this is a 6 and this is 5. So this answer is between 5 and 6. So that's all you're supposed to know. So this is the second question. Here is the logarithm expression. So they did give us this, right? The question, how do you say this expression? The different way you can say logarithm, logarithm to the base 2 of 64. You could also say logarithm of 64 to the base. So the main reference is the 2. Okay, that's how. Explain in your own words what the expression. So what do you think this expression, when you write down, what does this mean? It's so this means the base, how many times? So how many times do we multiply 2 to go to get 64? This also basically means you don't know what is this answer, right? Put a question mark. It means this 2, the base 2 raised to the box, this you don't know, equals 64. So this is the same equivalent form called logarithmic form. So this is called logarithmic form and this is called exponential form. So the logarithm is basically you get because of this expression. And you do know 2 raised to 6 is 64. You can check that out, right? Why? Because if you multiply 2, 2, 2, 2, 2, so 6 of them say, you get 64. So that's correct. So the answer is 6 here. That's all it is. And then finally they ask, what is the value? Oh, that's what we got, 6, right? We are done. Next one. Okay, what is this, right? Question is, let's write up here. First one is logarithm of 100 to the base 10. Now, by common sense, we already know the answer. This has to be 10. And why? I put a question mark. Why? So how did you get this? So the main base is, I'll put a color here. So this is the main base. So you're asking this 10, so the pink 10 raised to what gives you 100, right? You can clearly see it has to be two, common sense. But sometimes you need to be careful. Or you don't know, just put a question mark there. I put it. So imagine we didn't know that. If you didn't know that, you just keep it as it is, right? And you just do the right side, and you can put it like an X. You don't know, right? And the right side is 10 raised to 2. Now see, the base is the same. 10, this is the same. So the exponent has to, when the bases are same, bases are equal, then the exponents also are equal. Are equal. So that means this x has to be 2. So x is 2. And the common sense that we use is true, correct? So that's the simple one. But if you see the second one is where a little confusion. So the second one is, what about this? Let's just imagine we don't know that. So this is 100, right? So how many hundreds do you multiply to get 10? So what this means is, how many hundreds do you multiply to get 10? And I will say, hey, I don't know. Let's put it x. So by definition of, so how did we get logarithm is this 100 become the base. So let's do some work. So 100, so this 100 is the base raised to the power. So you want to know how many of them, right? So you don't know. So put in x equals get 10. Now let's see how do we do this. So what? So now this basically means it is 10 raised to 1. So what I'll do is, can we write this as 10 raised to base as 10? The right side is 10. This one also we could write is 10. So it's like 10 raised to the power 2. 100 is 10 square and there's an x there, right? Equals 10. So this means we can multiply power of power, that is 2x equals 10. 10 raised to 1. See, now we have the same basis, and you can say, okay, this is 10, this is 10. So that this 2x has to be equal to 2x equals 1. So the answer is x has to be half. So that's how you figure out. Okay, what about this one? What is logarithm 4 to the base 2? So we don't know, put a question mark and say, hey, let's change it to the exponential form. So 2 raised to question mark is 4. It means 2 raised to question mark is 2 raised to 2. So this 2 has to be same. If you don't know that, oh, how many times? We can use our common sense. You already know the answer. It has to be 2, right? So let's see. If you don't know, you just put an x. So this x has to be 2. So x is 2 and you're done. See how they trick us this. Now this time they ask you, second part is logarithm of 4 to the base 2 is what? Right? Question. So you don't know, put an x. So it means 4 raised to x is the 2. And then this basically means 2 raised to 2x equals 2. And this 2x is same as 1, so 2x becomes 1, so you get x equals half. You get the answer. And finally, let's say how do we write this? And it's a express b as a power of a. So the third one is a square is b, right? And there's a slight confusion. So this should be express a as a power of b should be this part. It means if you have this, so a is square root of b, or you can write b raised to 1 half, and that's all it is. So that's a simple question. Let's go. Question number 4 is, in order for this, which is increasing in the investment, which is increasing in value exponentially, to increase by a factor of 5 in 20 years. That means in the beginning 0 to 20 years, the factor that multiplies is 5. So we need to know, let's put it like f of x equals a times b raised to x. That's the exponential function that helps us to create. So based on this, so this factor 5 is for every 20 years. This is to every 20 years. So we want to know every year, right? So this b is basically every year. So for 20 years, so we'll have to split this into 20 years. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 3, 4, and 5. So that means each, so what should be for 1 year? So this is for, this one is like a B, but we want, what is this B, right? So that B, so how many B's? Let's see. So one B, another B, another B. So it's all these 20 B. See? So B, 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 B. We say B raised to 20 equals 5, correct? So therefore B equals 20th root of 5. And that is 5 raised to 1 over 20. So that's the factor of each year. This is each year. Now if you use the calculator, and on the calculator you end up getting that as 1.084. You can check that. What that means, it is 1 plus 0.084. It means it is 100% plus 8.4%. See? So the question is, what percent does it need to grow each year? So we say, hey, that's 8.4% increase each year. So I hope that helps. So the main thing is the visuals. Okay, every 20 years it is this part. So every year it is this part. And when you put in the calculator, you get this answer, and that's how I get it. So this is question number 5. So if you see, you're given a graph, an amount of chemical remaining after it was first administered or measured. The chemical decays exponentially because you can see the graph is going down. What is the exponent half-life? Now, what is that half-life of chemical? In the beginning, it was 800. So that means if this is the zero is 100, okay, and these are the weeks, this is the weeks, and this is the amount of calcium in milligram, amount, I can put it amount in milligram, and it looks like, so 100 to, you want to know, sorry, this is 800, so half of 800 is, let's see, 400, right? So when does that work? Like after how many weeks? And you can see there's 100. This is approximately, just go along this way and see, and then go down, and you can see that's 1.5. So you can see, so in 1.5 week, the amount of chemical will be half. Okay, so that's half. So half life. So what is half life here? Half life is 1.5 weeks. So every 1.5 week is what you get. And if you want to write also like every 1 week, now that's like 1, 2, and 3. This is 1 point. So there are 3 halves. If you want to, this is for every week, right? So, so this part which you see, I'll just take off this. There's a little confusion here. So this is 400. That's 1.5, right? But if you want to know exactly like 1, this is 0.5. So this becomes half. So the factor is 1.5, sorry, half. So this is half, the B, the growth factor. I'll put a capital B, a decay factor. But we want to know, let's see, every week. Okay, so if you want to write every, even though they did not ask you, and you can clearly see, first of all, there are 3 halves here. So this is half, right? So for every 1/2, it will be half raised to 1/3, right? So that means since we want to know the formula, let's see, if you really want to know amount remaining after every week, then what you have in the beginning is 400. And this, there are 2 of them here, see? So it's like this 1/2 multiplied by another one, half raised to 2/3. So it becomes half raised to 2/3, and W, 2/3, third into W. So this is for each week. Even though they did not ask us a question, but if they had to ask for every week, create a exponential function, and this is how you do, because this is 800. Sorry, 800 was what you had, and half is, so the half life is for every 1.5 week, but from here to here there are 3 halves, 1, 2, and 3. So we want to know for every half what is the growth decay factor, and that's what we found. One of this is for every like half of a week. But in a 1 week there are 2 halves, right? So you just multiply this to, hope that helps. So even though they didn't ask us question, but you're supposed to know here the answer is just half 1.5, because here you get 1.5 here and you're done. Okay, fine. So the question is, this is the 6th question. What is this, right? So simple. I mean, this is just you recall these are more problems which are from earlier lessons. So the only way is 10 times 2 is 100, right? So it's quite obvious. 100 is 100. Now the next one, what is this? 10 raised to what is 0.01? And what that means is 10 raised to this basically means this is 1 over 100, right? So the only way that works, which is 1 over 10 raised to 2, is this has to minus 2. That's it. This one is very clear that the right side is there are three zeros. Okay, and this has to be what, right? Question mark. So it has to be 3 because 1 raised to 3. So we get 3 is the answer. For this one, 2 raised to, now 2 raised to 1 is 2. So 2 raised to minus 1 is half. That's it. What about here? Half raised to 1 is 2, half. So, so here, half raised to minus 1, so you have to write the reciprocal of the C. What is minus 1? It's the reciprocal of whatever. So you have A over B and raised to minus 1 basically means B over A. So you use that rule here and say, hey, if it is minus 1, it has to be 2 over 1 raised to 1, which is 2. So hope that helps. So explain why this is correct, 1, right? So first of all, let me write logarithm of 1 to the base 10, and I don't know. So because I don't know, I'll put it at x. So this I want to change. So what does log means? You use this base and ask how many times you, so how many of this 10, this x gives you 1, right? So, and the only option this is 10 raised to 0 is 1. 2x is 1 and you're done. So the final question is, how are these two are related? Again, remember this is exponential form and this is logarithm form. Why? So when this is written down, it's the same as, so what is this means is logarithm of 100 to the base 10 is 2. What does that mean is asking a question. What are you asking a question? How many times do you multiply the base 10? This one, this is the 10. 10 base 10 to get this 100. So so we multiply 10 times 10 is 100, right? So that means 10 raised to the power is 100. So this right here is the same thing. Both are same. The only thing this is called exponential form and this is logarithm form. So this completes unit 4, lesson 10, practice problem. Hope this helps. Make sure you write all the work to turn in on your hard copy. And so the more we do all this, it will help you to master.